So really, one of the most important part of this subject starts right now with a data modeling tool, which we call it the relational data models, and that's what you will be using for designing your databases in this course, in this subject, sorry. We said that each data model, or a data model, is a tool for representing data and relationship amongst data. So that each data model should have some kind of representations for data items and relationships and all other things that relates to the data and relationships. First of all, I'll cover a few terms and definitions, and I ask you please to be patient with me, and then you will see how they all link together with the data model. In a database approach, or in a database, we store the data in tables. Right? And if you think of a table, like a Microsoft Access file, it consists of columns and rows. Right? That's just what the table is. So, so we store the data in a table. So each column name is the name of the data item that we are going to store. So for example, column 1 could be a student number, column 2, student name, column 3, student address. And then in the rows, we store the actual student number, name, and address of each of our students. So when we entered all the data, we've got the name, address, and the student number of all the students in the table, in the rows, and each column tells you what each data item is about. So we store the data in tables. A table is also called a relation. So when you read the book, if it says a relation or a table, it's the same thing. Right? So a relation and table is the same thing. The name of the columns, you see the title of each column is the attribute of a table. So for example, the table a student, if you call the table a student, has got 3 columns: a student number, a student name, a student address. Each of these columns are an attribute. Okay? So the an attribute is the name of a column in a table. Then with each data item, we say, has got a type of value and a domain or range of values. And these are the allowable values that you can store in each attribute, in each table. Every row in each table in table of students represents the details of one student, the student number, name, and address. So the row in a table is called a tuple, or a row in a table. All right? The number of attributes in a table is called the degree of that table. So the student table has got 3 attributes, or 3 columns, so the degree is 3. Cardinality is the number of rows. So if you've got 210 students, and we store all the details of the 210 students in the table, we have got 210 rows of data in this table. So the cardinality is 210. These terms are useful, or these definitions are useful when you want to communicate with each other. So there's no ambiguity, right? So we use the same term. So when I say, okay, a table in a database, you know it consists of rows and columns. The columns are the attributes of this table. The table has a name, and the rows contain the data of data that we want to store. So in a relational database, And that's what we will do, because we work with the relational data model and we build relational databases. And I will go to more details very soon. Consists of collection of tables. So a database consists of collection of tables. Each table representing an entity. What is this?
Yeah, are we going to be referring usually as relations or tables from now on?
Tables. Yeah. Yes. Yeah. We refer to tables as tables. You know, if you say relation, it's okay, but we basically say tables, and in industry we say tables. So a table represents an entity. What's an entity? An entity is an item, an object, something that we are interested to collect data about. Or it could be a person, like a student. Could be something like subject or course. Could be a vehicle. Could be a book. So if you think of a book in the library as an entity, so that the details of the books in the library will be stored in a table called book. And this table has got attributes. And the attributes together represents an entity. So an entity to be represented, their details are stored in attributes. So attributes of a book could be title of the book, name of the authors, name of the publisher, the ISBN number, the price of the book, the date of publication, place of publication, right? So, in a relational database, we have got large number of tables, each table representing an entity. Each entity or each table has got lots of attributes. Each attribute is a piece of data that when you put it all together, represents this attribute. So have a look at these two tables. It comes from your book. So we have got a table branch and a table staff, right? Or entity branch or entity staff. Entity and table and relation, same thing, right? So the entity branch is stored in a table, in a database, and the name of each entity has got a name. Each table has got a name. The name of your entity and the table is the same thing for the same entity. So the branch is the name of your table, and the attribute of branch is the branch number, street, city, and postcode of the branch. So you see the column names in here. Branch number is one attribute, street is the second attribute, city is the third attribute, postcode is the fourth attribute. So when we design our database at the beginning, there's no data. We're just looking at the data items that we need. And each data item attach itself to one or more entities. So if you look at the table staff and we want to store the staff details, so we have got the table staff or entity staff, and the attributes of the staff is shown here. So for example, a staff number, first name, last name, positions, gender, date of birth, salary, and the branch number in which they work. So with each attribute, we've got some metadata attached to them. So that's first the type of values they can have, right? The definitions of that attribute, and here it is. For example, if you look at city, is the name of a city, and the meaning, the set of all city names in which we have a branch. Okay, this comes from your book, says Britain, because the book is written by a British author. And then it says the size of the city name, 15 letters, or 15 characters. So here is the same thing, and same terms with different alternatives. So relation is a table, tuple is a row, and attribute is a column in a table. So a relation or a table is defined by the relation name or table name and set of attributes name. Right? So a relational database consists of set of relations and the relationships amongst those relations or tables. And we'll see how it happens, how it works. One of the things that you have to remember is that in a database, when you're designing a database, each entity name is distinct. You could not have two entity names that are the same. Does this make sense? So, for example, if you are designing a database and for a driving school, and you have got instructors and admin staff, so you could not have two tables called the staff. So if you want to separate the admin staff details from instructors, one of your table will be called staff or admin staff, another table will be called instructors, driving instructors, right? Or you just create one table called the staff and you put all the instructors and the general staff together. Right? So each entity, each table has got a unique name. The attributes in a table are unique. You could not have two attributes with the same name in the same table. But you could have the same attribute name in many different tables. Yeah? So the attribute names or column names are unique. When you store data about the students, so we said we create an entity called student with the attribute the student number, name, and address. So this is a unique name. So we have only one relation, one table in the database or in our design that's called a student, and has got three attributes. Each attribute is different, has got different name: student number, name, and address. Right? Then in this table, a student, we stored the details of all our students, only once for each student. So we don't store any student data twice in the same table. Why wouldn't we do that? The person that asked all the questions. Yes, sir. You. Why wouldn't you store the same student name twice?
You're searching by name,
Yeah, because if you're searching for a student based on their name or a student ID, you should only get one row of data coming out of this table. If you have two rows, that's a problem. Because if the student changes their address, you have to update it twice in this table. And it's not necessary to store the same data item or the same information twice. Does this make sense? So that's why we store each data in a table once. So that's what we say. Each data or each tuple, each row consists of a data about one member of that entity, and that's different. So you don't store the same data in a table. Order of attributes has got no significance. So you could have the first column as a student number, second one a student name, third column as an address, or you could have the first column as a street address, the second column as a name, and the third column as a student number. So there is no importance and there is no significance in the order of the attributes in your table. Order of and when you store the data about all your students, you can store them based on their student number in a ascending or descending order, or based their names, or no order, doesn't matter. Okay, theoretically. Of course, if you store them alphabetically, when you do search, it may be faster to access the data. Maybe. But don't forget, if you do that and a new student comes into this course, I have to create a new row in a certain place and push everybody else's data down. So that's where the problem comes. So the order in which the tuples are stored, the order of attributes have got no importance.